Testing, testing, testing. Hi there, guys. My name is Rohan Beve, and today we are going to be talking about shear stress and shear strain. We're going to be talking about, well, shear stress and shear strain. Okay? So, what really happens when you cut a cake? Okay, you take a knife, okay, it's maybe your birthday or whatever, and you cut a cake. What type of stress happens here? We know in physics what's happening here to the cake is called stress. This type of stress specifically is called normal stress, since the stress is perpendicular to the object, okay? So you cut it. But what about the cross-sectional area? That is also experiencing another type of stress. It doesn't look like it, but believe me, there is some stress going on here. But it's not perpendicular just like the normal stress. No, no, no. It is parallel. It is parallel stress, okay? And if the cross-sectional area is parallel, then that means it is experiencing shear stress, okay? So that's what's happening right now. So it's right now experiencing shear stress. Okay? So then due to this, it'll cause plastic deformation. So this is not much of a good example to put this on. So let's go onto a more better example. This is just a real life example if you can think about it. So what happens with regular stress and strain? For a little recap, let's say we get this two-dimensional beam, okay? We apply some force on it, right? On this area, okay? Area being for A, the cross-sectional area. Stress equals to F over A, F being the force and area being the cross-sectional area. And normal strain, as we see, it counts to the length of it, and delta L, which is basically how much has the beam changed, okay? So strain would be delta L over L, okay? So that's normal stress and normal strain. But instead of putting the force like this, what if instead of from top, we do it like this? We push it to the side. Instead of it being perpendicular, we put it to parallel, okay? So what if we pushed the force from here and we pushed it like this? And we must assume that the beam has a fixed base. Let's say that, okay? So when we push this, right? So what is shear stress? Mathematically, it's the same formula as regular stress, okay? Nothing really changes that much, okay? So that mainly happens, okay? So there's the force area, you push it, it experiences stress. Basically the same. As for the deformation, on the other hand, it would look something like this. Sorry for my poor drawing skills. It would look something like this, okay? So that way you can draw like a little line here, right? It just shows from where it originally was supposed to be to where it was now, right? And you can see a varying gap, okay? So let's look at the maximum displacement. Let's call this delta x. And how tall this is from the bottom, the top area, from the fixed base to delta x. Let's call this L, okay? So this is basically next to each other, right? And this also creates an angle. Let's call this angle theta, okay? So we have angle theta here. So what shear stress is of course basically the same thing as normal stress, well, formula-wise. But shear strain, on the other hand, is the tangent of theta. Yes, shear strain is the tangent of this angle. But how? Well, if we can put it like this, we can put it like this. Shear stress equals to the opposite over the adjacent. So we could put it as the opposite being delta x and adjacent being L. So we could put it to delta x over L. So that's basically what shear stress and strain is. And that's basically it. Thank you for watching this video and hope to see you next time. Bye bye.